welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as ever on the bench, and today we've got a lovely old amp. It's a Fender Tweed DeLuxe 1955, I believe this was made. Let me just check. Yep, 1955, so quite an old girl this one. The customer wants me to look it over and do the minimal upgrade or repairs that are necessary, consistent with making it work properly. It's always a difficult decision this on an old amp. You know, do you strip out all the components and bring it up to spec, bring it up to new standard really, or do you just change the components that are actually faulty, leaving other components that are marginal, leaking, not in tolerance, or do you change just the out of tolerance components? It's a very difficult kind of aesthetic stroke money decision really. A bit like kind of doing up an old car. To what extent do you take out all the original components and put in new, or to what extent do you leave old original components which aren't actually very good and might fail? So always a tricky decision. Anyway, the customer on this one wants me to do the minimum consistent with making it work. So the first thing to do, let's get the back off and see how original this amp is and what, if anything, might need doing to it. Well, here we are on the front side. Not too bad condition really. I mean, this amp is nearly as old as I am. I was born in 1953 and this is, so I'm older than the amp actually. So this is about 68 years old and I'm currently 70, amazingly. I know you're all clapping your hands to your forehead and saying, what? No, God, 70 can't be. So here we are. It's in quite nice nick really, considering it's as old as it is. And then we'll spin it around and have a little look on the inside, and you can see here that this amp is fairly original. It's got all the original red Ariston, I think they're called, Aston caps in, and these mini-mite electrolytics. Of course, these are well past their sell-by date, but we'll have a look to see if they are actually leaking, and if they're not leaking, we're not going to change them. It's got a couple of new valves in at some point. Look, someone's put some groove tube valves in. That's the rectifier. That'll be okay. And I expect to find a kind of motley selection of valves under these covers here. What have we got? We've got a groove tube, so that's been replaced. Look, at some point. And what's this one? That's not a groove tube, so that's a tongue sole. Look, that's quite a new valve, so that's been changed. Someone's revalved the amp, and I think the customer told me that they had also put in a 240 volt mains transformer, because this was originally 115 volts, 120 volts, and as you can see, that does look fairly new, that transformer, so that's new. So we're going to have an inspection of these electrolytics to see if they're leaking. I probably won't be able to show you that because I need to get kind of up underneath there, and I don't like these red caps, they leak. So I think we'll power it up as well and have a little listen to see what we think is going on with the amp. Okay, we're plugged in and turned on. It's got two channels, there's an instrument channel and a mic channel. It's a bit hummy when I turn it up. Yeah, that's better. That was a bit dull. Sounds sweet. Bit of a background hum there. Let's see what the mic channel's like. Yeah, a bit of hum on there too. Doesn't really sound any different, of course. Okay, so basically the amp is working. Always a good sign. Yes, now you might struggle to hear this, but as I turn this instrument volume up, Can you hear that kind of? Now what I think that is I don't think that's a dirty pot. Eventually you learn to hear the difference between the sound of a dirty pot and the sound of DC on a pot. And I think this has got DC on the pot. When it's got DC on the pot, it makes a sort of continuous round the dial. Whereas when it's dirty, it has dead spots. You kind of go. If you know what I mean. So there's sort of dirty spots on the pot. So a continuous scraping noise is DC on the pot. Anyway, we can certainly check that. I'm also wondering whether that hum is leaky electrolytic capacitors or failing electrolytic capacitors. We can check that quite simply by sticking a capacitor across there and see if the hum goes away. Right, let's get up on the bench and do a few things. Well, since my mind's on the subject, the first thing I'm going to do is to use my little homemade capacitor discharge tool plus capacitor. So there's a 100 microfarad 450 volt capacitor inside here. It's quite useful for testing capacitors just simply by sticking another big one across it. So if one of these electrolytics is failing and we put a big capacitor across it and the hum goes away, we'll know it's definitely the capacitor. So to do that, we just clip on to the negative. It'll be a bit of a bang as I touch it on here as it charges up. Okay, that's now fully charged. The hum hasn't changed. Let's try this one. Aha! Oh no. No, that also hasn't changed the hum. And I press the button on my discharge tool which discharges the internal capacitor rather than the quick way I did it last time. And finally, try this one. Nope. So interestingly, all of those 3 electrolytic capacitors are working well, and the hum is not caused by that. That's one thing out of the way. Now the other thing we can do is quickly measure whether we have any DC on that pot I was worried about. I would actually expect to see a couple of volts or a volt or something DC. I don't know if you can see the meter. I will read off anyway what it says. So we're just going to go now onto the wiper of the pot in question, which is there. And we've got half a volt of DC there, look. That's what's causing. Whereas if we go on the tone pot, there's half a volt of DC there as well. How about this one? There's no DC voltage on the mic volume. So these two pots here, the tone and the volume, have got DC on them. Can't hear that so much on the tone pot. Doesn't have that kind of scraping noise. Let's just check that. Half a volt there. Half a volt there. Okay. Well, here's one of the offending pots, and if we trace the wiper, I can see it goes off to this capacitor. Let me think, where is it? This capacitor here. So we should see, look, half a volt there, look, and half a volt there. So I think this capacitor here is probably leaking. On the other end of it, of course, we've got probably a couple hundred volts or something. Yeah, we've got 158 volts. Look, on one end of the capacitor. The capacitor's leaking slightly. There should be 0 volts there. Remember, capacitors don't pass DC, and we haven't got 0 volts. We've got half a volt. Now, another way you can prove that these capacitors are the problem, leaking, is you can heat it up a little bit with a hairdryer and see if that voltage increases. So I have a heat gun here. I'm just going to heat it up. That should do. And let's measure again the leakage. And it's gone up to a volt, look, 1.1 volts, which proves conclusively that this capacitor is leaking. Now, are any others leaking? There's a bit of leakage on all of these capacitors, apart from this one. Oh no, yeah, apart from this one here, this one's quite good. That's got 1.5 volts now as that's heated up. This one's got 19 volts on it, but I'm not quite sure. I would have thought that would be completely wrong to have 19 volts on that side of it. It's got 122 on that side, look. Not quite sure what this is doing, where it's going to. We could perhaps look at the schematic. But I don't think it should have 20 volts on it. So I think that one might be leaking too. This one's got 200 volts on that end and nothing here. Actually, it's got a volt. Okay, I think I might need to get the schematic for this just to familiarise myself with what this 0.02 cap is doing here. Because if that really has got 20 volts on it, and that should be ground, then this is really badly leaking. I'm just going to mark up the suspect cap, that one, and I'm a bit uncertain about this one, aren't I? Think that was right. Yes, there's one with 20 volts. Actually, I suppose we could just do a little trick here and see if that voltage increases. When we heat up that cap, then we know there's something definitely screwy about it, and it hasn't really. So we need to find out where that point is, what voltage that's supposed to be at. And this one's got 2 volts on it. Again, let's see if that gets worse. As we heat it up, it does. 3 volts, look. So 3 volts on that. 4 volts now, look, as it's heated up, so that one is definitely volty too. You know, we're changing 3 out of 4 of those caps. Just wondering whether to do them all, really. Let's just double check this one. 146 volts there and nothing on there. That's actually quite good, this one. It's just got 0.01, which is not very much. I want to leave as many caps as I can. So there's another funny one there. So here, look, on this side of the cap we've got I don't know why that's 53 volts. I'm going to have to look to see what that does. But on the other side of it, we've got 0.2, which means it's slightly leaky. So again, let's see what happens if we warm that one up. Was 0.2, now 0.7, you see. This is leaking as well. Hotter it gets, the leakier it gets. Well, I don't know whether I want to mess around trying to leave one capacitor in. I think, I'm afraid, if it was just one leaking one, we'd change it. But we've got 4 out of 5 so far, so we're going to change all those. There's no sign of leakage on these electrolytics, and when we dabbed a big electrolytic across them, the hum did not improve. So that tells me that these electrolytics are holding their own, and so we won't replace them. We'll just leave them, and if they go wrong at some point in the future, we can replace them. It's not a gig critical amp, this, so it doesn't really matter if it goes wrong at some point. This is a cathode biased amp, I believe, and there is the cathode resistor for the cathodes of these two power valves, and that's the cathode bypass capacitor going across it there. Okay, well, there's another little capacitor here actually, which is doing, that's probably a tone control, is it? Let's have a look. Tone control, yes, that's the tone control. There's a little tone control cap just underneath there, and I think that'll be okay. And we can just go around some of the resistors to check how good they're doing tolerance wise. I like to use this auto ranging meter for that. See if I can get it so that you can read it without the light glaring. So we're after 100k here, 120k, 116, they're a bit high those. That should be 820 and it's 800, that's okay. These should be, I don't care about those, they're the input resistors. 1k5 cathode bypass resistor, that's okay. 100k here, 100k, 56k, yep, that's okay. These are 220s, 240, a little bit high, 10% high. That one's okay. That's 1k5 there, yep, okay, yep, 1k4. So it's just these 100k, 113k, and 110k. They're okay, they're 10% high. Nothing there that is shouting out to be changed, so let's leave well enough alone. Okay, now next thing, let's go and see if we can find a schematic for a Fender DeLuxe 1955. Okay, this is what I believe to be the schematic for this amplifier. It's the 5E3 1955, and there's the 0.02 capacitor there that we were querying, and it goes from the anode of one of the 12AX7, so that's going to be HT, and it goes to the grid here, which is a virtual earth. Look, it's got that 1 meg going down to ground, so we shouldn't have had any voltage on there at all. And if you remember, we had a voltage there, so that proves that that capacitor was leaking. And here are some 0.1s here. Look, so for example, the grid, the anode of this 12AY7, that's interesting, I'll check that that's a 12AY7, 0.1 effectively going to ground, so we shouldn't have anything on that volume pot wiper. And if you remember, we had a voltage there too. Similarly down here, these are the two volumes, one for the instrument channel and one for the microphone channel. So we are going to change all of these 5 non-electrolytics because they're all leaking, and just for your interest, when I change them, I'll put them up on the Mega for you, and we can see, prove to ourselves that they are in fact leaking. Well, as you can see, V1 is a 12AX7, that's in here, and the schematic calls for a 12AY7. A 12AY7 is a low gain version of a 12AX7. From memory, it's got 60 or 70% of the gain. So putting this in will make this kind of louder and break up earlier, whereas putting a 12AY7 in will give it a bit less gain. I think I'm going to leave this valve in here and then just mention it to him in case he wants me to put a 12AY7 in. One other thing to notice is that you'll notice it has the switchable ground switch here, which puts the capacitors to ground. This was a kind of anti-hum thing, but of course it's very dangerous because if that capacitor fails, it's called the death cap. If that fails short circuit, then you have mains voltage going straight to the chassis, and your chassis becomes live. So normally one would remove this capacitor, and indeed if we look, we will see here is the ground switch. Here is one, and you might not be able to see, but there are no connections going to that switch, so that capacitor has been removed by somebody. So there we go, I've taken out all of these not very good quality old caps and replaced them with some decent 630 volt capacitors. They should be okay. So I think the next thing to do is to power up the amp and just make sure it's still working, and then I think we'll put these up on the Mega and just prove to ourselves that they are in fact leaking. Okay, the amp is plugged in and switched on. We're in the instrument channel. That's working well. Mic channel also working well. Sounds good. Still a bit hummy. Just to check whether you can hear maybe that scratchiness has gone out of that pot. It's now not making that noise. And in fact we can prove to ourselves, just for completeness. So there should now be no DC on the pot. Let's have a look. I'll go on to 2 volts. And the pot wipers here. No DC there at all. No DC there at all. And no DC there at all. So we've got rid of all the DC leakage that was floating around. So now let's have a look at those capacitors and see how leaky they are. Okay, we're now set up to test the DC resistance or insulation on these caps. In case you don't know, this is what's called a mega, and what it does is when you press that button it puts about 400 or 500 volts DC across this capacitor, and then measures any current that's going through it. So of course if this was a perfect open circuit, which it should be as a capacitor, would have actually no current whatsoever. If it's leaking, we expect to see this meter creeping up somewhere to show us how much current is leaking through this cap. So let's try the first one and see what that does. Whoa, look at that. Absolutely terribly leaking. So that's very bad. Let me just show you an ordinary new non-leaking capacitor. So if I put this across here, we should get nothing at all on this, and indeed we do. Look, absolutely nothing. Infinite resistance down there on that good capacitor. So this one's definitely no good. Let's try the next one. Leaking. If I were to heat that up with a hairdryer, this would go up. We might do that with one of the capacitors just for fun, but you can see that's leaking too. So that's 2 out of 2 so far. Let's try the third one. Da-dum. Leaking. Fourth one. Leaking. And the final one. Leaking, but not too bad. That's quite high resistance there. It's not open circuit, it's 100 meg. So that's the best of the bunch, that one. But still not good enough. So let's just now, for fun, put this on here. Measure the leakage as 4 meg. It says 4 meg resistance. Basically, that's like a 4 meg resistor. Should be infinite. And now let's warm this little thing up with a hairdryer. and you can see it's just getting worse and worse and worse the warmer it gets. So as this amp warms up, all these caps start leaking more and more, and now it's like a 500k resistor now, and getting worse by the minute. So there you go, that's absolute proof positive that all these capacitors needed changing. They're well known, by the way, these Astron capacitors. They don't last long. They're moulded paper. Oh golly. So there you go, and I'm going to put the back on this amp, just give it another quick test, and I think we can call it job done on that. Okay, there we go. I hope you enjoyed that one. A lovely little classic amp this, and we did exactly what the customer wanted, which was the minimal amount of changes consistent with getting the amp functionality pretty much where it should be. Of course, you can go on and on with an amp like this, change all the resistors, change the smoothing caps, you know, revalve it, just on and on really. But do you end up with the classic collectible amp that you started out with? It's always a very difficult problem, but I think the customer's got it right in this particular instance. Okay, I've got another one in from him. It's a 1959 Fender Champ. So Tweed also, so we're going to get stuck into that one now, and I may or may not make a video of it depending on how interesting it is. But anyway, as always, thank you for watching, and I'll see you on the next video.